Here's a short mini lesson on solving systems of linear equations. Before we actually jump into solving these systems, let's think about what solving a system actually means. So what we've learned so far when we're solving just a regular equation, maybe something like x plus 2 equals 5, our goal was to find out what is the value of this variable so that way it makes the equation true. And when you solve it, or you might even just be able to look at the equation, we can say, oh yeah, if x is equal to 3, then I know that this will work because 3 plus 2 is equal to 5. So x equals 3 would be a solution. So when we plug in the number 3, it makes it work. So now, how's this different from solving a system is what if I have more than one variable? Maybe I might say something like x plus y equals 5. Well, this isn't enough for, I can't just say x equals 3 because I don't have enough information here. Y could be 2, but I might also have x is 4 and y is equal to 1. So what we often find is they're going to give us two variables, but they'll also give us another equation to help us have enough information so that we can get it down to a single answer. So maybe we might also say that, okay, if I took x minus y, it's equal to 3. And you could always try to guess and check these, like again, 3 plus 2 is 5, but 3 minus 2 is not 3. 4 plus 1 is equal to 5, but 4 minus 1 is, and 4 minus 1 equals 3, so we might say, oh, that might be the answer. If I said x equals 4 and y equals 1, then this would be a solution to the system, because if we check this, 4 plus 1, x plus y, is 5, and 4 minus 1 is equal to 3. So x for 4 and y for 1, y equals 1, is what's going to be what works. So now, here I was just kind of guessing and checking, but we understand, hopefully, what it means to be a solution. Is that when we find the values for the x and y, so when you plug them in, it works for both equations. So there are a couple of methods for helping us find or solve for these x's and y's. And the two methods that I'll go over are the substitution method and the either combination or elimination is what people call it. So let's take a look at a substitution method problem first. So let's try this one right here. I have 2 times x plus 3 times y is equal to 1, and x minus 2 times y is equal to 4. So again, we need to find x and y, where if I plug into either one of these equations, it'll make it work. So the substitution method, the key idea for this method, and for actually both methods, is that we want to eliminate one of these variables so that way we can just use our normal methods of solving. And so using the substitution method, our goal is to try and get a variable by itself first. So we're going to get a variable by itself. And we can choose any of these any of the variables in either one of these equations, whichever one looks the easiest to get by itself. So for example, this x right here looks pretty easy for me. I can get that x by itself using our solving methods. And so all I'm going to do is let's add 2y to both sides of that equation. And if I do that, these cancel out, and I'm left with x is equal to 2y plus 4, or 4 plus 2y. And notice I have the x by itself now. So I'm just going to copy this top equation right underneath it. So here we go. We still have two equations, and we have one of the equations where the variable is by itself. So the second step for the substitution method is actually doing what the method is called. We're going to substitute. So here, what am I going to substitute is we got a variable by itself, in this case x, so that way we can substitute something in for x, because when I have x equals something, it means this x is the same as this right here. Like just like a substitute teacher. If I were to have a substitute teacher, then someone is going to replace me. You're going to take its place. So these two things are the same. So it doesn't matter if I write x or if I write 2y plus 4, they're going to be the same thing. So in this case, since I have x equals 2y plus 4, and I see in the other equation there's an x here, then we can replace that x with a 2y plus 4. So all I'm going to do is going to rewrite that second equation with 2x plus 3y equals 1. So notice this is exactly the same thing I wrote above, 2x plus 3y equals 1. The only difference is we're not going to replace, or we're not going to write the x anymore. We're going to write this 2y plus 4 in its place. So this is the substitution method, where we're substituting. And then all we have to do is solve this new equation. Because if you notice, when I did the substitution, there are no more x's in my equation. There are only y's left in the equation, so I can solve for y. So if I distribute, I get 4y plus 8 plus 3y is equal to 1. Then we can solve this by combining my like terms. So I have 7y plus 8 is equal to 1. And we can start getting y by itself. So I'll do minus 8 on both sides. And I get 7y is equal to negative 7. And then if I divide by 7 on both sides, we get our final answer of y is equal to negative 1. So there we go. We know one of the numbers that's going to work for both of these equations is the variable y equals negative 1. However, as we saw before in the original examples, is we need to know the values of both variables, not just y, but x and y. Well, if we look back up, it doesn't matter where we start off at, but we can actually figure out any x that I want that'll work if I know what y is. Because if we look back at this equation here, if I plug in y, then I can solve for x. So that is the last step, is to plug in and find the other variable. So let's do that. So I have x is equal to 2y plus 4. Well, we know y is negative 1. And so this is going to give us x is equal to negative 2 plus 4, which is equal to 2. I'll put on the next line. And there we go. We have two values. We have x is 2, and we have y is negative 1. And so this would be our solution. Now, how can we check that this is actually correct? Well, let's go back up to our original problem. And let's see if I plug those in, if it actually works and makes the equations true. So, 2, negative 1. So we have 2. I'll write it up here again. So our final answer was 2 comma negative 1. So again, this is our x, this is our y. Let's check the first equation. So I'm going to plug it into this first equation. 2x plus 3y is equal to 1. Now let's fill in x was a 2 and y was a negative 1. And we see we get 4 minus 3 is equal to 1. Yep, that one works. And let's check the second equation. We have 2 minus 2 times negative 1 is equal to 4. Well, this is 2 plus 2 equals 4. And yeah, that's true as well. So we see that 2 and negative 1 is what gives us the answer to make both of those equations true. So again, what were those steps that we did? using the substitution method, we first get a variable by itself. Then we substitute using that equation where we got it by itself and solve. And then once we have one variable that's solved for, then we plug it in and get another variable by itself. So that way you can have both variables. So now let's take a look at that same problem and let's solve it using the combination method. So the idea of the combination method is the same as we're trying to eliminate one of the variables so that way we can solve for the other. The only difference is we're not going to use substitution. We're going to be adding equations together so that way one of the variables disappears. And so let's break this down again into steps so we can see. So our first step is our goal is to make sure everything lines up. So we want to line up all the variables. The equal sign and the numbers. So what do I mean by that? If you notice, it's actually already done that for us in this problem. Here we have the x's are right on top of each other, the y's, the equal signs, and then just our constant numbers. Everything is all lined up directly in front of each other. And they're all in the same order. So once we have that, it makes it easy for us to add downwards when they're all lined up. So second step is we want to make sure that we're actually going to eliminate something, and you'll see how this works in a second, but we're going to multiply, and we're going to either multiply one equation, both equations, or but you're going to have to multiply in the equations so we have opposites for one of our variables. So it's up to you what you want to choose, but it's useful to try and find out which one looks easiest to get opposites. So for example, if I choose my x's, those to me look pretty easy. Right now I have a 2x and a 1x. So I want them to be opposites, like 2 and negative 2, or 6 and negative 6, or something like that. And I can get opposites very easily here, is if I were to multiply this bottom equation by negative 2. So what we're going to do is I'm going to multiply this bottom equation by negative 2. And let's see what happens. So the bottom equation becomes negative 2x, and I'm going to distribute to everything in the equation. So negative 2 times negative 2 is positive 4y. And also on the other side of the equation, to keep it equal, negative 2 times 4 is negative 8. So again, everything's still lined up, but everything got multiplied by negative 2. Then I'm going to recopy the top equation right on top of it again, so we have it always stacked up. Now if you notice, our x's, because I multiplied by negative 2, we have a negative 2 and a positive 2. They are opposites. So after we have opposites, then what we're going to do is we're going to add straight down to eliminate a variable. So if you notice here, when I add straight down, 2 and negative 2, they cancel out because we got opposites. Here I have 7y when we add 4y plus 3y, so I'm going to add those together. And on the other side, negative 8 plus 1 is negative 7. And now we can solve for y. And I get y is equal to positive 7 here. Y is equal to negative 1, which is the same variable that we got from the last solution. Once we have our y, again, we need to figure out x. So it's the same thing. All we have to do is go back to an original equation. We're going to plug in and solve for the other. So I'm going to take our y and plug it into either one of these equations, right? Both of these were the equations that we started off with, so I'll choose either one, whichever one looks easier to you. I'll do it with the bottom one, since the x looks pretty easy to get by itself. So I have x minus 2 times y is equal to 4. Well, our y is -1, so I'll plug that in. And let's see what I get. X plus 2 is equal to 4. Then we can subtract 2 on both sides. And I get 2. And there we go. We have the same exact answer because it was the same exact problem, just two different methods of getting there. So 2 for x, -1 for y.